Hey guys, for today I'm going to be showing how to create interesting geometries, kind of like double curvature surfaces and created by two planes. So pretty much showing you how to attach objects and create bridging objects, double curvature surfaces, which ultimately will then be possible to create hexagonal poly surfaces to then print and set up as 3D print files. Cool, so I guess we will start with creating two planes. Plane here, and a plane, change to pink. Cool, what we're going to do is we're going to copy, actually before we do that, we're going to edit the segments. Maybe actually I might just leave it to 5 just for simplicity's sake. So we're going to copy now, copy, and we're going to move it up a bit. So what we want to do now is we pretty much want to turn one object into an editable poly for further processing, and what we're going to do now is we're going to attach this object to this plane. The reason why we want to do this is because we want to be able to edit both geometries within the same scene. What is also important to note is that we didn't get to mention before was that when we copy an object, the normals of a plane will be, I guess, exact to what was copied or parallel to what it is shown in this case of the two planes. This is important to note because when we start modeling and create bridges between objects, it can become problematic, which I will show you. So if we go edit poly and select surfaces, select surfaces and then we select another surface. What we want to do with the bridging is we want to create a smooth, bridge between these two poly surfaces. But because these two planes are the normals of the planes are, parallel to one another, they will be creating a bit of weirdness. As you can see here, yeah, it will twist and bend and create really undesirable geometries. So what we need to do is we need to select a plane, and then we want to rotate this 180 degrees. So therefore, the normals of the plane are rotated and pointing downwards away from the other planar surface. We can see that this methodology now we can bridge the two objects. And there you go. So now it's created a way more correct geometry. So what we did now is we made a bridge between two planar surfaces or multiple planar surfaces. This bridge will now become our thing that kind of ties the two 2D planes. With the bridging modifier, we can increase the segments for further manipulation. We can also taper the object. We could also change the tapering, the location, and we can also smoothen it out. Looks pretty good. Okay. What I'm going to do now is I'm going to select that and increase it a bit. Yeah. Cool. Spice things up, make it a bit different. I guess we'll twist it. Using twist metaphor, we can change the angle of the twisting. Kind of looks like a mushroom, kind of cool. Kind of complex-ish. So now we can we want to play with the poly surfaces of the geometry, create more of an interesting pattern, and ultimately have a really complex poly grid. And then we start deleting from the poly surface itself to create a more structural system, like a lattice-like structural system. what we want to do is we want to subdivide the poly surfaces. This will triangulate the surfaces. As you can see, it creates small triangles on these square grids, but where we can adjust the parameters, the sizing. We're going to keep it for now, but we're going to be mesh smoothing it. By mesh smoothing the object, creates a bit more of an interesting patterning on the poly surfaces, just because it is a method of subdivision. We'll choose classic just because it provides a bit more of an intricate formation upon its gridding surfaces. To get it to a hexagonal gridding, we have to increase the strength so it looks pretty good now, but as you can see, there are some inconsistencies on geometries. The dark red spots, the way we can do that is we can vertex weld. Cool. So as you can see, the inconsistency have somewhat gone away. If it isn't, we can increase the threshold, which then will, weld the vertices together. So what we want to do now is we want to edit the poly surfaces. So then we start creating our lattice-like structure. Edit poly. Cool. And then we want to select the poly surfaces. And then we want to inset. With the important thing with inset is that to not fall into the trap of insetting by group. What we want to do is we want to inset each poly surface based on its centroid. So we change it, reverse the selection from group to polygon. So as you can see, there's pretty hectic. So we just decrease that. It's probably because, even if I reduce it, it's probably because of the unwelded vertices. So if we go back to vertex weld and we increase the threshold, and you go smoothing out and making the geometry more homogeneous. So we go back and we go insert, increase that. Cool, it's looking pretty cool. As you can see, the inset of the poly surfaces are producing a really interesting shape. What we want to do now is we're going to delete these poly surfaces to leave the geometry with the lattice-like structure. To do that, we delete the mesh. And really important thing to note is when to never delete things from 3ds Max, and to do it through the modifier list only, because if you delete it on your keyboard, it will be lost forever and you can't control Z. So it's really important. So if you want to delete mesh, you can turn it off and on, or just delete it. Cool. So now we've got our interesting lattice-like structure. What we can do is we should mesh smooth again to create a bit more of might just turbo smooth. Turbo smooth is another modifier that pretty much creates really interesting shapes, that turning harsh edges into more curvature surfaces by increasing the meshes. So cool. Now that we have our turbo smooth object, what we're going to do now is we're going to get it ready to 3D print. Turn off edge surfaces. So it's pretty dark. We'll turn it to high quality, just so it's nicer lighting. What we want to do is we want a shell object. Cool. For 3D printing to recognize an object, it requires a specific thickness, which shelling provides a thickness, either outer or inner, which we can adjust accordingly. By adding a thickness, we can ensure the capabilities of 3D printer being able to handle the structure to be handled with 3D printing. So I hope that helps. To further process the object through 3D printing, you probably have to go to the MakerBot website and download the MakerBot software and upload their file for further processing. I hope my video was helpful, and if you have any questions, please feel free to ask.